Okay, so I'm doing spiral 2. Okay, let's get started. I'm going to start at the bottom, and I use the divisibility rules first. Is it divisible by 9? Well, to be divisible by 9, I have to add all these numbers, all the digits, and make sure that 9 goes into the sum of all those digits. 3 and 4 is 7, plus 4 is 11, plus 7 is 18, and 18 with these two 6 is 12, so the sum here is 30. Is 30 can be divisible by 9 evenly? No, it won't work. So that's definitely, so right now here, I know it won't be divisible by 9 because I added all the digits, and the digits is 30, and the sum is 30, and 30 is not divisible by 9 evenly, right? 9 doesn't go to 30 evenly. So I know it's going to have a remainder here. So let's make sure it does. By 9, 3 times, which is 27. Then I have a 7 left over, 4 comes down, 8, 7, 2, 2 left over, bring the 7 down, 3, 27, 0, bring the 6 down, 9 doesn't go, that's a 0 by the way, 9 doesn't go into 6, I put a 0 here, bring the other 6 down, 9 goes to 6 7 times, which is 63, I'm going to have 4 left over. So the final answer is 38307, remainder 4. 9 can go into that big number, 38,307 times, but with a remainder of 4. So, but we already knew that because we checked with the divisibility rules that it was not going to work out nicely. So 36, another way of thinking of 36 is 4 and 9. Another one is, let's see, 3 and 12. So whether you choose this or this, that works. So we can test this number to see if it works for 4 and 9. If it does work for both numbers, then it works also for 36. Is it divisible by 4? Well, let's look at the last two numbers, which is 53. 53 is not divisible by 4, so that's an X. So already I can stop because it's not going to be 36 will not go into 60,953 evenly, so I already know that. But let's double check anyway for 9. 9 is 6 plus 9, which is 15, plus another 15, that's 30. And 30 is definitely not divisible by 9, so no twice. So definitely, when we divide, we're going to have a remainder again. Goes one time, 36. I have 24 left over, bring the 9 down, that's going to be a 6. 6 times 6 is 36, carry the 3, 6 times 3 is 18, plus 3 is 21. 3, bring the 5 down, that looks like a 8. No, wait, 9. Will it be 9? No, let's check. Times 9, it's 54, goes 5, 27, 32. Yeah, well, 9 times. So 54, carry the 5, 27 plus 5, 32. And I have a 11 left over. Bring the 3 down. That's going to be 3 times, right? Because 36 times 3 is 18, 108. I have 5 left over. So we knew it was going to have a remainder 5. Okay, it was not going to divide evenly. So there's all the work. Make sure you write why it worked and why it didn't work here. So we used divisibility rules for 4 and 9 because 4 times 9 is 36, and we needed to make sure that it worked for 4 and 9 in order for it to be divisible by 36. But it didn't, so it didn't work for 36. And we're going to do it again. 41. Do you know any two numbers that multiply give you 41? It's a prime, so you actually just have to divide this. Like, there's no divisibility rules I can use. 41 is the same thing as 1 times 41. It will work for 1, but I have no idea if it will work for 41, so we actually just might have to divide here. Divide by 41. Yikes. 7? No, 6. So let's see, 6. 6 times 4 is 24. I'm going to have a 5, 15, bring down, not 4, definitely 3. 12, borrow 4, 2, 12 and 3 is 9. Bring down the 5, and that's going to be a 7. Yeah, 7 works. 7 times 1 is 7. 7 times 4 is 28. 8 to bring the 2 down, and that's going to be, actually it worked. Wow. 41 goes 2 times 82. So this one, it worked. Oh, we didn't know because there was no way to check except by dividing, right? Because that didn't help us in the beginning. 18. I can think of 18 as 2 and 9. I can think of 18 as 3 and 6. So whichever of these two you choose, you got to make sure that it works for both factors in order for work for 18. So let's just choose 2 and 9. Will it work for 2? Yes, it's an even number. Will it work for 9? Let's see. 2 plus 2 is 4, plus 5 is 9, and 9 is divided by 9. So no remainder here. It will work. 18 goes into 22 one time. 4 left over. 45. 18 will go into 45 two times, which is 36. And we're going to have 15 minus 6 is 9. Bring the 9 0 down. 18 goes into 95 times. Yeah. 5 times 8 is 40. Carry the 4. 5 times 1 is 5. Plus 4 is 90. There you go. This worked out nicely. So I knew 18 was going to be, the number was going to be divisible by 18 because we used the divisible rule for 2 and 9, and both of them work, so it would work for 18. If you did the same thing for 3 and 6, it would also give you the same answer. Find all the factors. Oh, a lot of you forgot factors here on the test. So 1 and 64, look how far apart I wrote them. 2, yes it will, 32. 3, it's not, because 6 plus 4 is 10. So that's not going to work. 4, yes. 4 and 16. 5, no. 6, no. 7, no. 8, yes, it's 8 times 8. 9, no. 10, 11, 12, 13, 14, 15, 16. I already wrote it. I know I have all my factors. So this one was a repeat, right? So I know that this is a composite. Check. Is it prime? No. Is it a perfect square? Yes, because 8 times 8 is 64. So this is a composite and a perfect square. You see it in MERP? Obviously not, because it's not even prime to begin with. 91. 191. Is it divisible by 2? No. By 3? No. Because 9 plus 1 is 10. 4? No. 5? No. 6? No. 7? No. 7. Wait, 7. Did I say 7? No. So for 7, the rule for 7 is here's your 91, right? Take this number and double it. What do you get? Times 2, you double it, and you get 2. And you subtract this from the remaining number, which is 9, and 9 minus 2 equals 7. And is 7 a multiple of 7? Yes, it is. So for 7 is what work. Oh, careful. 7 and, well, the only number multiplied by 7 that's going to give you a 1 at the end is 3. So you're going to know it's 7 times something that ends in a 3. And this one could be 13. 7 times 3 is 21. Carry the 2. 9. So that works. 7 and 13. There we go. All my factors. Is it a prime? No. Is it composite? Yes. Perfect square? No. Is it MERP? No. Expanded form, word form. So word form, 7 to the third power, or please, 7 cubed. Exponential, 7 to the third power. Standard form, 7 times 7 times 7, which is not 21, it's multiplied. 7 times 9 is 49, times 7, 3, 6, 28, 343. 12 squared, squared means second power. Expanded form, 12 times 12, which is 144. 121, it's 11 to the second power, which is 11 times 11. Or 11 to the second power. 64 is 6. Oh, oops. 6 to the fourth power, which is 6 times 6 times 6 times 6, and I have no idea what that is. And I times 6 times 6 times 6 times 6 times 6 equals 1,296. I think it's 36 times 6. Why do I just do this? Which is 36 with 3, 216 times 6. 36, I'm right. 1,296. Okay. Find prime factorization, write it in exponential form. 25 and 10. 2 and 5, circle, circle, 25 is 5 and 5. So, I know that it's 2 times 5 times 5 times 5, better yet, 2 times 5 to the third power. This is what I want. 1008, ugh, ugly number. So 2 and 504, circle, 2 and 252, 2 and, I have no idea, 252, divided by 2, 126. This one might be a long one. I can use not 3. Let's use 3. 3 and 42. Yeah. 6 and 7. Sorry, circle, circle, and 6 is 2 and 3. Wow, that was a long one. So it's 1, 2, 3, 4 twos. 1, 2, 3, 4 twos. 2 threes. 1, 7. Make sure you write a little dot next to each between these. 2 to the 4th times 3 to the 2nd times 7. There you go. Find the GCF by listing all the factors. Yeah. 28 and 42. So let's look at the factors. 1 and 28. 2 is a yes. 14. 3 is a no. 4, yes. 4 and 7. 5, 6, and 7. So good. 1 and 42. 2 and 21. 3 will work. 3 and 14. 5, no. 6, yes, because they were for 2 and 3. So 6 and 7. And that's it. Common factors. 1, 2, they share this. They share the 2s. 3, 4, and they share the 7. So the GCF is 7. It's the biggest of all of them. 72 and 90. 1 and 72. This might have a lot. 2 and 36. 3 and 24. 4 and 18. 5 is a no. 6 is 12. 7 is a no. 8 is a no. 8 and 9. 10, 11, 12. Oh my god, a lot. 1 and 90. 2 and 45. 3 is a yes. 3 and 30. 4 and did that 4 work? 4 and no. 5 and yeah, that 5 and work. 16. No. No. Did I say 15? 5 and 18. Sorry. 6. We were for 2 and 3, so definitely 6 is going to work. 6 and 15. Okay. 7, no. 8, no. 9, yes. 9 and 10. 11, no. 12, no. So that's it. Common. 1, 2. 1s are in common. The 2s, the 3s, the 6. There's a 9. There's an 18 here. So GCF, this one's a big one. 18. Use the ladder method. Oh, I'm pretty sure you prefer this one. 5, 3, and 15. Go again. 3, 1, and 5. So the GCF is these two numbers. Equals 15. So you definitely can see that the GCF using the ladder method is much easier, but you definitely have benefits in using the listing because you actually can see all the factors and see which one's the greatest common factor. So 3 numbers. Again, GCF, it's 2, 12, 16, 32. 2 will go again. 6, 8, and what's this, 16? I can use 2 again. Oh my god. 3, 4, and 8. Well, with GCF, we'll stop because you have to find a number that goes into all 3 of them. So GCF is the product of those numbers, and 2 times 2 is 4, times 2 is 8. Okay. Multiples. Oh, that's it. Okay, so multiples by listing. Ew. Good luck there. So let's do the easy one. 20 times 1 times 2 times 3 times 4 times 5 times 6 times 7. I'll stop there. 14 times 1 times 2 is 28 times 3 is 42 times 4, 56 times 4 again is 670, 84, 1, 2, 3, 4, 5, 6, plus 14 again is 98. Can you understand now why listing multiples like this is a little bit too much? 12, 98 plus 14 is 112, plus 14 again, 126 plus 14 again is 140. There's your LCM. Okay. 9 and 25. Oh boy. 25, 50, 75, 150. No, sorry, 100. What am I doing? 100, 125, 150, 175. This is going to take forever. No, so now 9, 18, 27, 36, 45, 54, 63, 72, 80, 1, 90, 99, 108, plus 9, 117, plus 9, 126, plus 9, 135, plus 9, 144, right? Plus 9, 153, plus 9, 162, plus 9, plus 9, 171, plus 9, 180, oh my god, 189, plus 9, 198, and that's assuming I did everything correct, plus 9, 207, plus 9, 216, plus 9, 225. Okay, let me stop there. 175, 200, 225. There's your LCM. And again, assuming I did all my addition correct, I would have gotten the right LCM. So again, benefits, you can see the LCM. You can see that what, down the line on the times table, the 9 and 25, you'll meet, there's a number that's going to be 25. There's probably more if you go on, but we want the smallest one. Okay, thankfully. So, ladder method comes in handy. Okay, they each have their own advantages and disadvantages. So 2 works, 9 goes into 30, 15. We're going to go with 3. 3 goes 9, 3. 3 goes 15, 5. So the LCM is all these 4 numbers. LCM is 2 times 3 times 3 times 5. 5 times 3 is 15. 15 times 3 is 45, and 45 times 2 is 90. So the LCM is 90. It's 3 numbers. A little slight difference in how we do 3 numbers with LCM. Okay, just be aware of that. Can I go with 2? I can go with 2 for 2 numbers, so that's okay. So 2 goes into 20 10 times. 35 doesn't work, so write it down. And 2 goes into 42 21 times. Can I look at 2 numbers, at least 2 numbers, or something that goes into 3? Yes, I can. I found one. 5 goes into 10 2 times. 5 goes 35 7 times, and 5 doesn't go to 21, so I write it down. Can I continue? Yes, 7 and 21. So 7 doesn't go into 2, so write it down. 7 goes to 7 1 time, and 7 goes to 21 3 times. Now, I can't continue. There's no 2 numbers, at least 2 numbers I can continue. So the LCM is going to be a big number. It's the product of all these numbers. The LCM is 2 times 5 times 7 times 2 times 1 times 3. Ugh. All right, so let's start. 2 times 5 is 10, times 7 is 70, times 2 is 140, times 1 is 140, and times 3 is 12 plus 1, 420. So the LCM of all these three numbers, 20, 35, 42, is 420. Okay, I hope that helped. Okay, and that's that. So that's spiral 2.